Morning, Piper. All right, let's get going. Any questions on interval notation from the worksheet yesterday? Questions on interval notation? Okay. Make sure that all gets turned in on Teams. Let's knock out our last class and then go on spring break. Okay, so we're going to do 10.6 today. I'm just going to warn you, 10.6 is a bit more challenging than the previous one. Not as challenging as maybe 10.4a, but it's not as challenging as yesterday. It's more challenging yesterday. There, I said it correctly. So yeah, we will definitely have to come back and probably review this class when we come back on that Monday after spring break. So here's your homework. It's 1 through 12 all. Sounds like it should be pretty simple. Half of it is, half of it's a little bit more challenging than the previous half. It is all new though, so you've never done this before. So you definitely, absolutely, positively have to pay attention. As a note to some people, I'm kind of noticing a pattern on homework, especially the ones where I give you all the answers. I'm having a lot of people just turn in an answer sheet that just has answers and there's no work. Piper, you're not one of them. But I'm having people turn in an answer sheet alone, and there's just no possible way that you can do this without work. I need to see your work. Let's be prudent. Let's be honest on our homework. You're not getting any practice if you're just copying down answers. The reason why I provide answers is so that you can be confident that you're doing them correctly. You know, it's a horrible thing, especially in a math class, to do 5 minutes worth of a problem and then find out you got it wrong and have no idea why you got it wrong. So make sure you're honest about your work. I guess I'll leave it at that. By the way, I always find out who's honest and who's not come test day when you can't do the problems. And yet you turned in miraculously all your homework with all the answers. All right, so here we go. So 10.6 is something about absolute value equations and inequalities. Basically, we are going to be solving equations that involve the absolute value symbol, or we'll be solving inequalities that use the absolute value symbol. In the big picture here, like I said, if you pay attention, it's not that bad, but it is absolutely brand new, and you got to wrap your head around the concept. All right, so this is, I would definitely call this a challenging day. All right, hopefully it turns into easy for you. So 3 things. Let's see how much of this we can get through. So think about this. If I literally give you this, well, let's see what this means. It means that the variable x is equal to the one number, 9. Right? There's not 2 answers here. There's one number. It's literally that x is the value 9. If I give you this, however, put those absolute value symbols, well, here's the problem. There ends up being 2 numbers that can make this true. If I plug in 9 to the absolute value of 9 is 9. But if I throw in a negative 9, I get exactly the same answer. The absolute value of negative 9 is also 9. So here's the issue. The issue is that the absolute value of x equals 9 has 2 answers, 9 and negative 9. So when we get to solving an equation, this is where we're going with this. When we solve an equation that has the absolute value in it, we end up with getting 2 possible answers, because eventually, once we do some algebra steps, we wind up with the absolute value on one side, a number on the other side, then there's 2 numbers that can make it true. When you solve an equation, just a regular old equation, let's say it says x plus 1 equals 9. When you solve this one, subtract 1 for both sides, we only get one answer, 8. When you solve an absolute value equation, we will get 2 answers. 2 answers. And that's what this class is about. All right. So with that out of the way, we're going to be solving both equations and inequalities today. So there are a bunch of steps here. Since this is a video, I'm not going to pause and have you copy this all down. I want you to rewatch the video, and I want you to pause the video and write these steps down. Okay? So I'm not going to wait for everyone to copy this down. I'm just going to move on. We will use all of these steps, but you're definitely going to want to write these steps down. So here we go. So how do we write the two equations? Once we get our equation down to the absolute value symbol on one side and a number on the other side, we simply write the two possible answers. There's two numbers that can make this true, the positive value of 9 and the negative value of 9. So once you get it down to this in blue, absolute value on one side and a number on the other side, you simply write both the positive and the negative value of that number, in this case 9. All right. So we're going to jump right in. This is how it's done. Step number 1, and it says use algebra to get the absolute value symbol by itself. Remember, in algebra, we've always been getting the x by itself. Now we're just going to add one extra little thing. I want you to get the absolute value symbol by itself. In other words, we need to get rid of this stuff right here. So it's normal algebra, nothing changes. To get rid of positive 2, we subtract 2 from both sides. So we subtract 2 from both sides and we get that. As soon as you get your absolute value symbol by itself, isolated on one side, we're going to write two equations. The first equation, we get rid of the absolute value symbol and just simply write whatever's there. Hey, 7 was there, so we write 7. The second equation, because remember 2 values make this true, is we write the opposite of 7. The opposite of 7 is negative 7. So here are the steps again. We isolate the absolute value symbol using regular algebra. Hey, get rid of addition by subtraction. Get rid of multiplication by division. We just do algebra. We eventually get the absolute value symbol by itself. Then we're going to write two equations, one without the absolute value symbols, one without the absolute value symbols, and the opposite of whatever number appears right smack here. So most kids are like, oh, once we get here, we just write 7, negative 7. Those are the two numbers that make this true. Now, we as mathematicians are lazy. I mean, we are efficient. And so we have an easier way of writing two equations equal 7 and negative 7. We just say x is equal to plus or minus 7. New symbol. This one right here. This one right here. New symbol. That's the plus or minus symbol. Check it out. Throw that back into here and watch it's true. So 7 plus 2 is 9, or absolute value of negative 7 plus 2 is also 9. Okay, two numbers that make that equation true. We need to see that again. Let's see that again. So we're going to get the absolute value symbol by itself. So what do we need to get rid of? I need to get rid of this 2 right here. How is 2 attached to the absolute value symbol? It's attached through multiplication. We get rid of multiplication by division. So we divide both sides by 2. That's easy. 2's cancel, and we're left with the absolute value of x is equal to 5. We write the two equations now. The first one is just erase the absolute value symbol. The second one is write the opposite of 5. The opposite of 5 is negative 5. Okay? So the two answers are x is equal to plus or minus 5. Check that out. Put a positive 5. The absolute value of 5 is 5. 5 times 2 is 10. Put a negative 5. The absolute value of negative 5 is 5. 5 times 2 is 10. There's the two numbers that make this true. So it's not a complicated procedure. Let's see that again. Get the absolute value symbol by itself. Hey, let's get rid of this minus 5. Add 5 to both sides. So we get the absolute value of x is equal to 6. We write the two equations. The first one is positive 6, and the second one is negative 6. It's literally that simple. That's how you solve an absolute value equation. We write your answer as, plus or minus 6. Eventually, we will get to where they will have two answers, and these two numbers will not match. I won't get a 6 and negative 6. I might get a 2 and a 4 or something like that. We'll see that here in a little bit. But when the numbers are the same, the only thing that's different are the signs. You can save yourself a little bit of time and write plus or minus. All right, questions? All right. Let's see that again. The steps say get the absolute value symbols by themselves. Here comes a complicated one. Notice absolute value symbols right here are by themselves. There's nothing attached to them. That plus 3 is on the inside of the absolute value. That's fine. We're trying to get literally the absolute value symbols by themselves. They're by themselves. So we immediately jump to step number 2. We write the two equations. We erase the absolute value, write positive 4. We erase the absolute value symbols, we write negative 4. You see what I did there? Get the absolute value symbols by themselves, step 1. Step 2, write your two equations. Now we solve. We're going to get different numbers this time. On the top one, we subtract 3 from both sides, we get 1. On the second one, we subtract 3 from both sides, we get negative 7. The two numbers that make this true are 1 and negative 7. Hey, this is a compound answer right here. I didn't say compound inequality, it's a compound answer. It could either be 1 or it could be, it doesn't have to be both. It could be 1 or the other. They both make it true. Check it out. 1 plus 3 is 4. The absolute value of 4 is 4. Negative 7. Excuse me. Negative 7 plus 3 is negative 4. The absolute value of negative 4 is 4. There are two answers there that are wildly different, but they both make the absolute value equation true. Getting the hang of it? Let's see another complicated one. Our goal is to get the absolute value symbols, those two vertical lines, all by themselves. So I need to get these two vertical lines all by themselves. Well, what's attached to it is this 2. So get rid of the 2. 2 is attached to the absolute value through multiplication, so we divide both sides by 2. The 2's cancel, right? The 2's cancel. 10 divided by 2 is 5, so we get absolute value of t minus 1 is equal to 5. Set up the two equations. We set up the two equations. That would be t minus 1 is equal to 5. All we're doing is erasing the absolute value symbols. And the second one, same thing, t minus 1, but equal to negative 5. In other words, we're just writing 5 and negative 5. Solve each one separately. The top one, what? We add 1 to both sides. So t is equal to 6. Second one, add 1 to both sides. That would be negative 4. So my two answers are either t could be 6 or t could be negative 4. 6 or negative 4 makes this true. It's hard to see because of all the algebra there. If we remember that and we go back to the original equation, let's go back and, and throw in 6 or negative 4. Let's see. 6 minus 1 is 5. 5 times 2 is 10. Negative 4. Negative 4 minus 1 is negative 5. The absolute value of negative 5 is 5. 5 times 2 is 10. Those two values make it true. Those two values make it true. Either a 6 or a negative 4. All right, this is as complicated as it gets this year. Check it out. I need to get the absolute value symbols by themselves. So what's attached to it that I need to get rid of? I need to get rid of this 2 and this positive 1. Of the 2, always get rid of addition first or subtraction first. So to get rid of that plus 1, we subtract 1 from both sides. I'm not sure why I put the line there. It should be underneath, right? I should put the line right here, not there. That means division. All right. 9 minus 1 is 8. To get rid of the 2, we divide both sides by 2. 2's cancel. 8 divided by 2 is 4. So we get absolute value of t minus 1 is equal to 4. Write the two inequalities, or two equations, sorry. T minus 4 is equal to 4, and t minus 1 is equal to negative 4. You should be comfortable with this pattern now. See, on the top one, add 1 to both sides. That's t is equal to 5. 5 makes this true. Second one, add 1 to both sides. Negative 4 plus 1, negative 3. So the answer is t is equal to 5 or negative 3. Two very different answers. 5 minus 1 is 4. 4 times 2 is 8. 8 plus 1 is 9. Negative 3. Negative 3 minus 1 is negative 4. The absolute value of negative 4 is 4. 4 times 2 is 8. Plus 1 is 9. Two very different answers. They both make that equation true. Questions? All right. There are 3 problems. Pick 2 of them. Pick 2 of them and do them, please. Pick 2 of them. I'll give you a 30-second head start. Riley, you came in a little bit late. We okay?
For the last problem, why was there a -4 as well?
The last one?
I mean, negative. So for this one, why did we do -4? Like find 2 of them.
Are we okay to get to that part right there?
Yes.
So then we write 2 equations, because remember, the absolute value can always give you 2 answers. So the steps are, we break this up into t minus 1 is equal to 4. We just erase the absolute value symbols, and then we do the same thing, but write -4. So +4, -4. That allows for the 2 possible answers. And the part that you missed when you came in late is, if I just write the absolute value of x equals 9, well, there's 2 answers for this. If I plug in a 9 or a -9, in other words, plus or minus 9, both make this true. So when you solve for it, you have to account that there are 2 possible answers. So that's why we write these 2 equations, one where the 4 is positive and one where the 4 is negative, and that allows you to get your 2 answers.
Okay, thank you.
Okay. All right, let's see. On the first one, okay, so we got to divide both sides by 2. That gives me f plus 4, absolute value of f plus 4 is equal to 2. We write the 2 equations. The first one is just f plus 4 with the 2. And the second one is an f plus 4 and a -2. That allows for our 2 possible answers. And then we solve each one separately. Subtract 4 from both sides, so f is equal to -2. Subtract 4 from both sides, and we get a -6. So these 2 answers, -2 and -6, can make this whole thing true. -2 plus 4 is -2. The absolute value of -2 is 2. 2 times 2 is 4. -6 plus 4 is -2. Absolute value of -2 is 2. 2 times 2 is 4. On the second one, get rid of the -1 first. So add 1 to both sides. You get 3 times the absolute value of f minus 3 is equal to 2 plus 1 is 3. Divide both sides by 3. And we get the absolute value of f minus 3. 3 divided by 3 is 1. Write our 2 equations. F minus 3 is equal to 1, and f minus 3 is equal to -1. Solve both of these. And the cool thing here is that they're both solved the same way. You just add 3 to both sides. If I add 3 to both sides, 3 plus 1 is 4. I add 3 to both sides. 3 and a -1 is a 2. So I get the 2 answers, 4 and 2. 4 and 2 make this true. 4 minus 3 is 1. 1 times 3 is 3. 3 minus 1 is 2. 2 also makes it true. 2 minus 3 is -1. The absolute value of -1 is 1. 1 times 3 is 3. 3 minus 1 is 2. Last one. Well, the absolute values are already by themselves, so I just get rid of them and write the 2 equations. So the 2 equations would be 2f plus 9 equals 13. And the second one, 2f plus 9 is equal to -13. Solve both of those equations. Subtract 9 from both sides. 2f subtracting 9 is equal to 4. So f is equal to 2. Subtract 9 from both sides. So we get 2f minus 9. That would be -22. I just subtracted 9 from both sides. Divide both sides by 2, and we get f is equal to -11. Watch, 2 times -11 is -22. -22 plus 9 is -13. The absolute value of -13 is 13. 2 2 times 2 is 4, plus 9 is 13, absolute value 13, 13. They both work. All right, questions? That's how you do them. That's how you do absolute value equations. Well, it'd be nice. Here's it nice and pretty. I would absolutely 100% recommend that you play the video. Play the video while you do the work. Okay. Quick note, you might see this on one of the problems, right? Check this out. It says the absolute value of x plus 1 is equal to -2. So clearly the first thing you do, you just subtract 1 from both sides, and you get this answer. And if you're not careful, you'll immediately say, well, x is equal to +3 or -3. Well, here's the issue. Look what it says. It says the absolute value of x is equal to -3. There is no number that you can throw in. There's no number that you can throw in here and then take the absolute value and get a negative number. This is a tricky one. It only happens rarely. If you ever get the absolute value symbol by itself, and on the other side of the equal sign is a negative, this is a no solution answer. There are no numbers that you can throw into absolute value and it spits out a negative number. This only happens very rarely, but math books always love to throw this in occasionally. And if you're not paying attention, then it comes up and bites you in the butt. Be ready for that one. All right, last thing before spring break is we're going to do the same thing, right? We're going to do the same thing except with an inequality. For equations, there's 2 numbers that can make that true. For an inequality, there's an infinite number of solutions. Sounds like it'll be hard. It's done the same way, except one slight difference. The 2 things that can make this true, right, are 2 inequalities where the inequality is switched and the number is switched. In other words, you're writing the opposite. Remember, if this was an equation, right, we would write the 2 equations, one where 9 was positive and one where 9 is negative. Well, that's still going on here. But what's also going on here is that I am flipping an inequality. The first one, the inequality is not flipped. On the second one, the one where I write the opposite of 9, I flip the inequality. So those are the switch techniques that makes this one true. So the hardest thing to remember is that for the inequality ones, not only do you write 9 and -9, but on the negative one, you flip the inequality around. All right. Like I said, you may want to write this. As I said on the start, I'm not going to pause and have you copy down the steps, right? You can replay the video at your leisure and write down the steps. It looks like there's a lot, but basically I just explained it to you. You just simply solve it as you normally would solve an inequality. And when you get the absolute value by themselves, the first one, you just get rid of the absolute value symbols. On the second one, you flip the inequality and you make the number the opposite. Let's see how that works. All right, let's see how that works. Remember, we also are in the inequality land, so if you ever multiply or divide by a negative number, you got to flip the inequality, right? All right. Remember, if the thing on the other side is negative, you don't flip it just because the other side is negative. You flip it because you're dividing or multiplying by a negative number. So on this one, this one you flip. On this one, since we would multiply both sides by 2, you don't flip. All right, keep that in the back of your head. Here we go. Here's how it's done. It's the same way as equations, except if we ever multiply or divide by a negative number, we got to flip the inequality. On this one, all we're going to do is subtract 2 from both sides. We're not multiplying or dividing by a -2. Life is good. Here's where the difference is, right? When we write the 2 inequalities, the first one that we write is simply it without the absolute value symbol. The second one, we flip the inequality, we make 7 negative. That's how it's done. Okay. Well, here's the only issue is that it's an inequality, so we have to graph. Well, let's graph. It says the solutions are smaller than 7, but bigger than -7. Think about that on a number line. If you're smaller than 7, I wrote -7. If you're smaller than 7, but bigger than -7, this is an and. This is an and inequality. So if you're smaller than 7, but bigger than negative 7, that's an and one. We're either going to get an and or an or here. Okay? So when you graph these, just simply graph what it says. It says the solutions are smaller than 7, but bigger than negative 7. Here's it nice and pretty for you. Smaller than 7, bigger than negative 7. Let's see that again. Step number 1, get the absolute value symbols all by themselves. Hey, they're by themselves. Step number 2, you write the two inequalities. The two inequalities will be the first one without the absolute value symbols. Everything stays the same. And the second one will be without, but flip the inequality and make the number on that one side negative. You see what I did there? That's this step 2. I'm going to solve this now. Let's see. Subtract 5 from both sides. This will be a negative 4. The second one, subtract 5 from both sides. Gives me a negative 6. Let's see what our graph would look like. Don't overthink it. It says that the numbers are bigger than negative 4. Oops, sorry. Bigger than negative 4, but smaller than negative 6. So I always put the big one on the right side and the small one on the right side. I said that backwards. I put the big one on the right side and the small one on the left side, and then simply do what it says. It says x is bigger than negative 4. Notice it's going to be a closed circle. So if you're bigger than negative 4, your arrow goes in this direction. But if you're smaller than negative 6, it goes in this direction. So this one looks like an or. This one is an or. No, they're not going to ask you whether it's an and or an or compound inequality. You're simply going to graph what the answers tell you to do. All right, have I confused anybody? Here's it nice and pretty now. Well, maybe that's not as pretty as my other one. All right, let's see that one more time. Step number 1, get the absolute value by themselves. We need to get rid of this 3. It's attached by multiplication, divide both sides by 3. Remember, if I had just divided by a negative 3, I would flip the inequality. I didn't divide by a negative 3, so I don't need to flip the inequality. Hey, the absolute value symbols are by themselves. So we write 2 different inequalities. The first one is just you erase the absolute value symbols. The second one, you flip the inequality and you make the 5 negative. Hopefully you're seeing this pattern here. Now we solve each one separately. Top one, add 2 to both sides. Hey, that's a 7. The bottom one, add 2 to both sides. That's a negative 3. Now we graph our solution. You have 2 numbers here. You got a 7 and you got a negative 3. There's always going to be a big number and a small number. Small number goes on the left. Big number goes on the right. Now just do what it says. It's closed circle on 7. It's a closed circle on negative 3. This says that the solutions are smaller than 7, but bigger than negative 3. This one's an and. Shade in between. Riley, you tracking on this?
Yeah.
If you're lost, I know that everyone's lost. Piper, what do you think? Piper, you live? I can see you're trying to talk. I don't hear anything. Maybe her microphone's out. Okay. As I said before, I would probably recommend that you play this video while you're doing your homework. That could probably help you if you run into any issues. Do we have any time left? What time do we get out of here? We get out of here at 12 o'clock. What time is it now? Okay, we got 9 minutes. Plenty of time. Plenty of time. All right. No, here's a nice and pretty graph. All right, let's do one more. Oh, look, I was nice to you. The absolute values are already by themselves. We don't have to do anything other than write the 2 inequalities. So we write the 2 inequalities. The first one you write without the absolute value symbol. The second one you flip the inequality and you write a negative number. Solve each one separately. Looks like we got to add 7 to both sides. Looks like we got to add 7 to both sides. 7 minus 2 is 5. For me, I don't overthink this. I simply draw a number line. You're going to have 2 numbers. One will be big, one will be small. Put the small one on the left, put the big one on the right. Figure out if it's open or closed circle. Both of these are open circles. And then do what it says. It says the solutions are smaller than 9, but bigger than 5.
Mr. Chartier,
Yes,
you wrote a 7 and not a 9.
thank you. Why did I say, oh, because we're adding 7. Okay, I got hung up on that. Okay. Yeah, so you're smaller than 9, but you're bigger than 5. Well, that's an and. Once you do a bunch of these turn into be like no big deal. There's also a nice pattern between equations and inequalities, right? The only difference is on the inequality, occasionally you'll get hung up because you'll forget. Here's it, be nice and pretty. You'll get hung up because you won't be paying attention, and then you'll divide by a negative or you'll multiply by a negative and you'll forget to flip the inequality. That's probably the only thing that can happen. All right, here are 3 problems. Pick 2 of them and do them, please. Pick 2 of them. Piper, since I can't hear you, send me a quick chat. Just tell me, are you getting this or you're not getting this? Makes sense, Piper. Makes sense. So much of this high-level math stuff is it's just a matter of a little bit of practice and allowing yourself the idea that you don't understand it at first, but after a little bit of practice, it starts to make a bit more sense. I can't tell you the number of times that I've done something that's like, I don't really know what I'm doing. I understand the steps, but I don't know what I'm doing. Then all of a sudden, after the second or third example, all of a sudden things start to click and it makes sense. All right, let's see. The first one. Hey, I was nice to you. The absolute values are already by themselves. There's nothing I need to get rid of. So I write the 2 inequalities. The first one, you just write exactly what's there minus the absolute value symbols, 15. The second one, same thing, except you flip the inequality. So that less than becomes a greater than, you make 15 negative. We solve each one of these. Add 4 to both sides. Well, that would be less than 19. Add 4 to both sides, and we get greater than, add 4, negative 11. Number line. Small number goes on the left, negative 11. Big number goes on the right, 19. Looks like open circles on both of those numbers. It says y is bigger than negative 11, but smaller than 19. Hey, this is an and. Easy peasy. Second one, we got a little bit of work. We need to get rid of that 2. So divide both sides by 2. We're dividing by a positive number, so I don't need to flip the inequality. So we got absolute value of y plus 1 is greater than 5. 2 inequalities. Y plus 1 is greater than 5. And y plus 1 is less than negative 5. Solve each one. Looks like we're subtracting 1 from both sides. Minus 1, minus 1. So we get y is greater than 4. Subtract 1 from both sides. Just be careful. At some point, you may have to divide or multiply by a negative number. Y is less than negative 6. 2 numbers. Small one on the left, big one on the right. Negative 6, positive 4. Looks like it's open circle on both. Y is bigger than 4. Oh, this is an or. We're going on that side. Y is bigger than 4, but smaller than 6. Okay, no big deal. The book goes into a big deal about saying that, hey, you can tell from the very start of whether it's going to be an and or an or. It's great. If you want to read that, that's fine. If you just solve it, right, you'll know by the end whether it's an and or an or, because that's what the solutions will say. The last one, hey, the absolute values are already by themselves, so we simply just write the 2 inequalities. So 2g minus 1 is greater than or equal to 7. And 2g minus 1 is less than, and flip the inequality, negative 7. Add 1 to both sides. So 2g, if I add 1 to both sides, I get 8. If I add 1 to both sides, 2g is less than, add 1, I get negative 6. Divide both sides by 2. So we get g is greater than or equal to 4. And on this side, g is less than or equal to negative 3. Okay. Graph, big one on the right, that's 4. Small one on the left, that's negative 3. It looks like there's a closed circle on both. And I'm going to read it. G is smaller than negative 3. Oh, it's going to be another or, but bigger than 4. Bigger than 4. And once again, the book goes to tell you that, hey, look, if it's greater than, it's going to be an or it's greater than or equal to, it's going to be an or. If it's a less than, it's going to be equal to an and. I don't like this because it's because the variable is on the left side. If I flip the variable to the other side, then that little rule goes away. So I don't even make a point of, the book does, it spends a half a page talking about this, but I just say, just solve it. You'll figure it out whether it's an and or an or just by solving it. All right, any questions on anything I did? All right, get rid of my scratch work and put nice pretty. Here it is, nice and pretty. Okay, 2 ors and an and. Any questions on anything we did? Because I am out of time. It's time to go on spring break, or you guys got 1 class left and then it's time to go on spring break. Any questions? Give this a shot. I would absolutely positively say do this today. Don't wait till next Sunday when you don't know what you're doing. If you do wait till next Sunday, then absolutely positively play this video again. It is a Friday, so I did that slightly quicker than I would. We will do a review of this when we get back, and then everything else that we've learned. But you guys have a wonderful spring break. Do something fun since we've been on quarantine for the last 14 days, and I'm ready to get out. I know I'm going to play some golf tomorrow. And I will see you guys live on that Monday. I'm looking forward to it because I miss all you guys. All right. See you guys later.